Since the beginning of time, mankind has been fascinated by what lies beyond the Earth. In April of 1961, the first human was sent into space, and nearly 8 years later, Neil Armstrong became the first man to set foot on the moon. The United States had been working on sending a man to the moon throughout the 1960s, and through the Saturn V rocket program were able to do so. The Saturn V rocket was the most powerful rocket that had ever flown successfully at the time, and was used in the Apollo program throughout the 1960s and 70s. The first Saturn V rocket lifted off from Kennedy Space Center and performed flawlessly on November 9, 1967, and this is the launch that we will be focusing on. We will be attempting to calculate the velocity of the rocket at a certain moment in time, but before we do that, we must understand the situational factors that will help form the problem. This is the Saturn V problem. The Saturn V rocket took off at Kennedy Space Center, which is at Merritt Island, Florida. The rocket was launched from Launch Complex 39, which is a site whose facilities were originally built for the Apollo program. We are going back in time to watch the launch in person, and the best place to view a shuttle launch is the Kennedy Space Center Visitor Complex. The Visitor Complex provides the closest public viewing of rocket launches. These locations are typically a few miles from launch pads so that you can safely see and feel the liftoff of spacecraft leaving Earth. The distance from the Visitor Complex to Launch Complex 39 is approximately 7.5 miles. So, as we begin to set up our related rates problem, the base of our triangle becomes 7.5 miles. The Saturn V rocket stood a staggering 363 feet tall, which converts to 0.06875 miles. This value becomes the initial height of our triangle. Given these two values, along with data that was taken from the actual launch, the rest of the problem can be set up as follows. We've gone back in time to watch the Saturn V launch on November 9, 1967. We are going to record the launch with a camera so that we can show our family and friends in the future. At a given moment, the angle between the nose of the Saturn V rocket and the camera is 0.009166 degrees. This angle is changing at a rate of 0.231 degrees per second. Calculate the velocity of the rocket at that instant. Obviously, this triangle is not drawn to scale, but for visual purposes, here is what the triangle would look like. It's also important to note that we know the value of d theta over dt. The first thing we need to do to solve the problem is to find a relationship between theta and y, and we can find it using trigonometry. Tangent of theta is equal to y divided by 7.5. The next step in solving the problem is to differentiate both sides with respect to time, and then plug in what we know to solve for the vertical velocity, or dy over dt. After differentiating both sides, we come up with this. Since we already know what both theta and d theta over dt are, we can plug in those values and go from there. Doing that brings us here. Then, we can simplify, multiply 0.23 by 7.5, and reach our final answer. dy over dt is equal to 1.73265 miles per second. This means at that moment, the Saturn V rocket is traveling at 1.73265 miles per second. Following my calculation, I researched the real-world data regarding the speed of the Saturn V rocket, and it turns out that when Saturn V blasted off from the Earth, the first stage burned for 2.5 minutes, lifting the rocket to an altitude of 42 miles and a speed of 1.714984 miles per second. Until the end of time, mankind will continue to be fascinated by space exploration. Whether or not we will travel beyond our moon and deeper into our vast universe is yet to be determined. But one thing is for sure. We all have natural curiosity. Science is a process of investigating. It's posing questions and coming up with a method. Thanks for watching.